Hey everyone, welcome back. In this video, I'm going to talk to you a little bit about 3D printers and how they work. Currently, 3D printers are used by hobbyists to make all sorts of things. They're also used in industry to make everything from, well, buildings to food to even surfboards. Probably the most useful aspect of 3D printing is rapid prototyping, to literally be able to take what you design in computer modeling software or CAD software and literally make it right after you design it. So you can see your designs come to life. The most common types of 3D printers are called FDM printers or fused deposition modeling, like this Prusa right here. Over time, these layers build up or accumulate, creating your desired object. So in order to understand how a 3D printer works, we first must understand or look at the components that make up a 3D printer. So starting at the top here, the first thing you'll probably notice is this reel or spool of plastic. We call this plastic filament. The spool of filament here then sits on this, what we call a spool holder, and is allowed to continuously spin. Another feature seen here on the 3D printer is known as the gantry or the frame. And another feature here is what we call the lead screws, and these are typically used in Z or vertical and up and down movement. So they essentially allow your 3D printer to move up and down. And some of the other features here are these belts, okay, down here and right here, and these belts are connected to stepper motors that literally allow your 3D printer to move side by side and back and forth. And down here we have what's known as the build plate, and this is where all the action takes place. Okay, this is where the plastic is being deposited layer by layer. This is where essentially, well, like the name implies, your object is being built. And down here we have what is known as the LED screen, which is basically where you control the 3D printer. And you can control it by either pushing this or turning this knob here. And every 3D printer is different, but almost all 3D printers have some sort of LED screen, which allows you to control it. Another feature to consider are our X, Y, and Z rods here, which are basically allow, once again, the machine to make precise linear movements with these bearings in here. And back here we have the power supply, which supplies the machine with the adequate voltage. And then over here we have the board, which is like the brain or the microcontroller of the 3D printer. So a lot of 3D printers these days utilize what's called an enclosure. And an enclosure essentially surrounds your 3D printer and creates an ambient temperature inside the printing area. And it makes it easier to print more difficult things like ABS. And one of the most important components to consider here is the extruder. The extruder is responsible for pulling the filament in, melting it, and depositing it here onto the build plate. All right, so let's zoom in now to our extruder seen here. The first thing to notice here is our filament, and our filament is being pulled in here by these little wheels or gears here that are attached to a stepper motor. And this stepper motor essentially just pulls the filament in to what's called the heat sink. And the goal of the heat sink is essentially to distribute or dissipate heat until your plastic here comes all the way down into what's known as the hot end. Okay. And this hot end down here essentially just, well, it's just a chamber that melts your plastic. So the hot end here, also known as the heat block, like I said earlier, is where the plastic is being melted. And inside the hot end here, or heat block, is what we call the nozzle. So the nozzle here is where hot plastic is literally being squeezed or pushed out of to create the 3D printed object. And typically around the extruder here, you'll find one or more fans that are used to essentially cool the plastic as it comes out of the nozzle. It's also used to help cool and dissipate heat around the heat sink here. So in order to understand how 3D printers work, you first must understand the three principal directions a 3D printer can move in. So assuming you're standing in front of your 3D printer, 3D printers can move in a horizontal X direction, or essentially left to right. They can also move in a Y direction, or towards you or away from you. And they can also move in vertical or up and down Z directions. It is the ability to move in these three principal directions that allow for the machine to create or construct your 3D printed object. So if you recall, earlier I talked about the board. I mean, every 3D printer has what's known as a microcontroller or motherboard, just like the one seen here. So the microcontroller or motherboard is very important. The microcontroller or motherboard seen here analyzes the incoming G-code from your slicing software. G-code, in a nutshell as well, it's basically a numerical programming language used to instruct the machine on where to go. Okay, it uses X, Y, and Z coordinates similar to the X and Y coordinate system you learned in math class. And it basically tells the machine to move to different X, Y, and Z coordinates in space. So the board or microcontroller here converts the G-code into electrical signals that tells the stepper motors how and when to move. Okay, so stepper motors, well, they're kind of a unique motor. They're basically motors that move in steps or fixed or defined movements here. All right, so the board sends pulses of electricity known as pulse width modulation or PWM that basically instruct the motor on how long to move for, essentially telling it when to move and when to stop. So the motor is then connected to a series of pulleys and belts that translate a pulse of electricity into a linear movement. This process is then repeated thousands of times in the X, Y, and Z directions until your object has been successfully 3D printed. I hope you learned a little bit about 3D printers and how they work. Thanks so much for watching. We'll see you next time.